Okay, so let us see. In this part we will discussing some cash terminologies. Okay, so first we have already discussed capacity we have already discussed. That is the total size, the total data and instruction the cache can hold. The total size of the cache storage area, like example, like 64 kilobytes, it's usually in kilobytes and megabytes. Okay, now block size is like denoted by small b. Data is not moved between RAM and cache 1 byte at a time. It is moved in blocks, which is also called as lines. If the block size is 64 bytes, means every time the CPU misses the cache, 64 bytes are fetched from the RAM at once. This takes advantage of fact that if you need byte hashtag 100, you will probably need byte hashtag 101 soon. That means actually you have to understand, like in blocks the data is actually stored in the cache. Okay, so that means the data is like not moved like one byte, no, it is basically moved in blocks. And the block, different blocks of caches can have different caches can different block size. So let us say the block size is 64 bytes. That means at a time, if there is a CPU cache miss and all happen, what happen is that 64 bytes is fetched from the RAM. So what is the advantage of doing that is that the nearby address data can also become and can be placed in our cache. This helps us to access the other address data also, if that is used in the future. Understood? So now the cache has some number of blocks. Now how do we calculate? That means if you want to see, let's say this is a cache, and in cache like this blocks are there. This is how we will represent block. Let us say it is a 64 bytes block. So similarly there would be some number of blocks. So how do we calculate this total number of blocks which is present in the cache? The total number of blocks, which is denoted by capital B, would be given as is the division of the total cache capacity, division of the total capacity that the cache can have, divided by the block size b, small letter b. So that means the number of blocks b is C by b, that is block size, and this is the cache capacity. Understood? This is how you will calculate the number of blocks. So that means, let us say if I have the cache capacity as 64 kilobytes and each block is 64 bytes, that means I have, when I divide 64 kilobytes, that is with 64 bytes, how much number of blocks that the cache can have? That would be 1024 blocks, like that. That is how you calculate the number of blocks. Now the next thing is degree of associativity. Degree of associativity, that is capital letter N, it is denoted. This is the measure of flexibility, that is how many different places in the cache can a specific memory block be placed. That means how many slots in the cache, can a specific memory block can be placed. That means if let us say the n's value is 1, that means a memory block can only be placed in one specific slot. It is allowed, that is, if this is my cache, it has some blocks like this. Now in the main memory is little more bigger. I will draw main memory in little more bigger way, and there are some blocks in main memory also. Let us say like this. Now this is my main memory, this is my cache. Okay, so associativity N means the number, like this block can be, let's just name it as, for the understanding purpose, let us say each block as 1 2 3 4 5 6. Now where and all this block, this particular block can go? If n's value is 1, means only one position can this go, only in one position, any one of the position. But that can be, like if I say this is 1, only here it can go, let us say. But n's value 2 means this particular block in the main memory can go into any of the two blocks like this. That is flexibility. Okay, like how many slots in the cache can a specific memory block can go. That is called as associativity. Now this part right now just skip. We will discuss this part when we are talking about what is direct map, but what is fully associative, what is, these are belonging to the what mapping. So in that mapping, when we are discussing, we will learn this, what this actually means. Right now let's skip this part. Okay, just understand what is capital letter N, what is small letter B, what is capital letter B. That is what do we mean by block size, what do we mean by capacity, what do we mean by the number of blocks, what do we mean by associativity. Now number of sets means how many groups or row the cache is physically divided. Now I can divide, you have to understand here, I can divide the cache. Let's consider one example. This is my cache. Now I am dividing this cache into two groups. Like this has two blocks, this has two blocks. So this two, that means how many sets are there? Two. That is what set means. Set means how many ways I can divide this cache. So that means if the total number of blocks is 4, I can divide in the divide in such a way that one set can have two blocks and another set can have two blocks, right? So set means that is how many groups or row the cache can be divided. So that if you have 1024 blocks and the cache is four-way set associative means, the n's value is 4. That is what it means. This we will understand while we are discussing the mapping. So you have to just understand now how do we calculate the number of set. It is the number of blocks divided by n. That is the flexibility. N is what? The flexibility. That is the degree of associativity. So on this formula, that is the total number of blocks divided by set associativity, we can calculate the number of sets. So right now what we have discussed what is capacity, what is block size, what is the number of blocks. Number of blocks we calculate it by the total capacity by the block size. Then what is n, degree of associativity. And then we are discussing the number of set, that is S. That S value is the total number of blocks divided by associativity n. Okay, this much you just understand right now. This was the basic terminology here. Okay, which is used in the cache. This is the basic terminology which is used in the cache.